Hello everyone, in this video we will learn about the equations of straight lines and also we will learn about different forms of the equations of the straight lines. First of all, we go for the equations of the coordinate axis. When we talk about the x-axis, we can see any point P lying on the x-axis will have its coordinate in the form of x comma 0. It means y coordinate of every point lying on the x-axis is always 0, and hence we can say that the equation of x-axis is y equal to 0. Similarly, if we have any point q on the y-axis, the coordinates of this will be in the form of 0 comma y. It means the x coordinate of every point lying on the y-axis will be always 0, and hence we can say the equation of y-axis will be x equal to 0. After this, when we learn about the equations of the lines which are parallel to the axis, first we go for a line which is parallel to x-axis. We have here two lines which are parallel to x-axis at the distance a from the origin. This line is on the positive side, this is on the negative side, and we find every point lying on this line will have its y coordinate as a, because the distance from x-axis is a. And hence we can say that the equation of this can be taken as y equal to a. If the line is on the negative side, the distance is minus a, that is because of negative side, and hence the equation of this can be taken as y equal to minus a. Similarly, if we have the line parallel to y-axis, we have here two lines which are parallel to y-axis at distance b from the origin. One is on the positive side, another on the negative side. Will we find that every point lying on this will have its x coordinate as b, and every point lying on this will have its x coordinate as minus b, and hence we can say that the equations of the lines which are parallel to y-axis can be given as x is equal to b or x is equal to minus b, depending on their position, whether they are lying on the negative side or the positive side of the origin. When we talk about the different forms of the equations of the straight lines, what is the meaning of different forms, why they are required? Actually, to draw any of the line, what we need? Either the direction of the line and a point, or 2 points which are lying on that particular line, or joining which the line can be drawn. Like this, we have different conditions, and according to condition, whatever the equation we are getting, these are only making the different forms of the equations. The first form here is slope intercept form. Slope, we know what is the slope of a line, that is the tangent of the angle it makes with the positive direction of the x-axis. And the intercept on the y-axis is suppose c. So we are finding here the equation of a line whose slope is m, and the intercept on y-axis is equal to c. Slope is m. It means m is equal to tan theta when theta is the angle in the positive direction of x-axis which the line is making. So here theta is this angle and c is the intercept on the y-axis. This is this here, you can see here. Suppose we name this point as A. Then OA is equal to C. See now what we have to do, we have to take an arbitrary point P with coordinates x, y on this particular line, because we know that the equation of a line is first degree equation in two variables x and y. From P, if we draw a perpendicular on the x-axis, that is suppose PL, then will we find that OL is equal to X and PL is equal to Y. OL is X and PL is equal to Y. Then we draw a perpendicular from point A to this perpendicular PL, that is AM. Now in this triangle AMP, we can see that angle MAP is equal to theta because this is the corresponding angle to this. AM is equal to OL is equal to X. And what about PM? You can see here ML is C, same as OA, and that's why PM will be equal to Y minus C. For the slope, we know slope is the tangent of the angle. So if we go in this triangle AMP, tan theta will be equal to perpendicular upon base, that is PM upon AM. What is PM? We have seen here, that is Y minus C. What is AM? We have seen here, that is X. And tan theta we know is M. So we can write M is equal to Y minus C upon X. If we cross multiply this here, we find M into X is equal to Y minus C, or we can say Y is equal to MX plus C if we transpose this C here. And this is the equation of the straight line whose slope is M and the intercept made by that on the y-axis is C. The second form of the equation is known as intercept form. This is to find the equation of a line when its intercepts on the x-axis and y-axis are given. Intercepts on the axis are given. Suppose the intercepts are A and B. The intercept on the x-axis made by this line is A and the intercept on the y-axis is suppose B. To find out the equation of this particular line, what we do, again we take a point P here, the coordinates of which are x, y. If we draw a perpendicular from P to the x-axis, that is PL, then we know that OL will be X, that is the X coordinate of this, so OL is equal to X. Then what about LA? LA will be A minus X. PL is equal to Y, that is the Y coordinate of it. Now if we see these two triangles, triangle AOB and triangle ALP, in these two triangles what we find, we are finding that angle O is equal to angle L, that is 90 degree each. Angle A, this angle is common to both. So angle A is equal to angle A, that is the common angle. Can we say then triangle AOB is similar to triangle ALP? By what? By AA criterion. By AA criterion of similarity, these two triangles are similar. And we know if two triangles are similar, their corresponding sides are proportional to each other. Then can we say that OA upon AL, OA upon AL is equal to OB upon PL. By taking the reciprocals of them, we can also write this as AL upon OA is equal to PL upon OB. Substituting the values, what is AL? We have seen just now AL is A minus X. OA is A, the intercept on x-axis. PL is Y, the Y coordinate of the point P. And OB that is B. If we simplify this, will we get it as a upon a minus x upon a is equal to y upon b? This is equal to 1 minus x upon a equal to y upon b. If we transpose this, can we write this as x upon a plus y upon b equal to 1? This is the intercept form of the equation of the line. Here what are a and b? A and b are the intercepts on the x-axis and y-axis. The third form of the equation is perpendicular form, or we call it normal form, because the perpendicular is also known as the normal to the line. We can see here the line is AB, which is intersecting x-axis and y-axis at A and B respectively. What we have been given? We have been given the length of perpendicular from the origin to this line is P, and the angle which this perpendicular makes with the x-axis in the positive direction is alpha, or we can say this perpendicular is inclined to x-axis at an angle alpha. So what is given here? The perpendicular from origin to the line is equal to P in length, and this perpendicular is inclined to x-axis at an angle alpha. What we do in this case, the easiest way of finding the equation of line here is we consider that this OA is suppose A and OB is B. It means we are taking the intercepts of this line on the x-axis and y-axis are A and B, suppose. Then what we do, we will see this triangle OMA. This is right angle triangle. We are finding this OA is the hypotenuse and P is the base for angle alpha. So in triangle OMA, if we find the value of cos alpha, will that be OM upon OA? OM is P. OA we have taken as A. Can we find out the value of A from this? That will be P upon cos alpha. Similarly, if we go in this triangle OMB, in triangle OMB, this angle we will find is 90 minus alpha. We can write here this is pi by 2 minus alpha. And for this, if we go for cos of pi by 2 minus alpha, that will be OM upon OB. We know cos pi by 2 minus alpha is sin alpha. OM, that is P. OB, that is the length of intercept on y-axis, we have taken as B. From this we are getting B is equal to P upon sin alpha. Why we have done this? By finding the intercepts on the x-axis and y-axis, we can find the equation of this line in the intercept form. Therefore, we can write equation of line AB, that is x upon A plus y upon B equal to 1. This we have learnt just now. Substituting the value of A and B, we get x upon P upon cos alpha plus y upon P upon sin alpha is equal to 1. By simplifying this, we will get x into cos alpha upon P plus y into sin alpha upon P is equal to 1. If we take the LCM and transpose this P onto that side, we will get x cos alpha plus y sin alpha is equal to P. This is the equation of the straight line in the perpendicular form, or we say normal form. Here we have to remember that alpha is not the angle made by the line with the x-axis. This is the angle of inclination of the perpendicular to the line from the origin. And P is the length of the perpendicular or normal to the line from the origin. The next form is known as point slope form, or we call it one point equation of the line. Means what? This is the equation of a line which passes through a given point. Like here, the line is passing through point A, whose coordinates are x1, y1. And its slope is given, or the inclination with the x-axis in the positive direction is given. It means if theta is the angle it makes, then slope m is equal to tan theta. Passing through x1, y1. We have to find the equation of such line. We have already learnt about the equation of a line in slope intercept form. Slope intercept form. That is y equal to mx plus c. If this line is passing through the point A, that is x1, y1, means that point will satisfy this equation or not? Yes, it is to satisfy. So we can say x1, y1 lies on it. So what will happen? This equation is to be satisfied, means y1 equal to mx1 plus c. We have replaced y and x by the coordinates of the point. If we subtract this equation number 2 from 1, subtracting 2 from 1, what we get? We are getting y minus y1 is equal to, m is taken common from this, that will be x minus x1, and c will cancel. This is the equation we are getting, which is known as one point equation, means the equation of a line which is passing through a given point and its slope is known to us. Now the next is 2-point equation, means what? The equation of a line which is passing through two given points, like here it is P and Q, the coordinates of which are x1, y1 and x2, y2. So we are to find out the equation of this line. We have already learnt how to find out the equation of a line passing through this point P, x1, y1. So if we write this as number 3, then we find that the same line is passing through point Q, or we say Q lies on it. So we can say, since Q, that is x2, y2 lies on 3, therefore we will find y2 minus y1 is equal to m into x2 minus x1, which gives us the value of m, that is y2 minus y1 upon x2 minus x1. We have learned the same formula in the previous videos also, how to find out the slope of a line joining 2 points. If we substitute this value of m in this equation, then we can find the equation of this line or not? Yes. So we can write, therefore the equation of line is y minus y1 is equal to y2 minus y1 upon x2 minus x1 into x minus x1. And this is only known as the 2-point equation of a line. We can also write this as y minus y1 upon y2 minus y1 equal to x minus x1 upon x2 minus x1 by transposing. The same equation can also be written as y minus y1 upon x minus x1 equal to y2 minus y1 upon x2 minus x1. Anyway, You remember this, the equation of two lines is the same here. So like this we can find out the equation of a line joining 2 points, or we can say passing through 2 given points. We discussed now one of the problem based on the intercept form of the equation of a line. That is, find the equation of a line the sum of whose intercepts on the axis is 10 and it passes through the point 2, 3. How to find out the solution of such problem? What we do? We will consider the intercepts on the axis as A and B. So we write, let the intercepts of the line on the axis be A and B respectively. Then according to problem we have been given that A plus B is equal to 10, or we can say that B is equal to 10 minus A. We know the equation in the intercept form. Equation of line is x upon A plus y upon B equal to 1. If we substitute the value of B here, we are getting this as x upon A plus y upon 10 minus A equal to 1. Now, we can say this as 1 since the line is passing through the point 2, 3, or we say 2, 3 lies on this line. So, we can say it passes through 2, 3. So, this point will satisfy this equation. It means we can write that 2 upon A plus 3 upon 10 minus A is equal to 1. Simplifying this, taking the LCM A into 10 minus A, we are getting this as 20 minus 2A plus 3A equal to 1. Cross multiplying, we get here 20 plus A is equal to 10A minus A square. Transposing this here, we are getting A square. This is A minus 10A, that will be minus 9A plus 20 equal to 0. Now by using the split method, we can find the factors of it. That will be A minus 5 into A minus 4 equal to 0. It means we are getting the values of A as 5 and 4. Now we will have two cases and two equations we will obtain. So we are taking case 1, case 1. If A is equal to 5, B will be equal to 10 minus 5, that is also 5. And then we substitute these values of A and B in the equation, this x upon A plus y upon B equal to 1. This implies that the equation of line is x upon 5 plus y upon 5 equal to 1. Or we can say x plus y equal to 5. This is one of the answer. We can go for the second case, that is case 2. Here we have A is 4. If A is 4, B will be 10 minus 4, that is 6. It means the equation of line in this case will be x upon 4 plus y upon 6 is equal to 1. If we simplify this, we will get 3x plus 2y equal to 12. This is the second answer. So like this we get two equations in such case. So we can write therefore the equations of lines are x plus y equal to 5 and second is 3x plus 2y equal to 12. This is the answer. Like this, using these forms according to the requirement, and according to the conditions given, we can find the solution of any problem based on the equation of line. In the next video, we will be learning about the general equation of a straight line. Thanks for watching my video. If you have any comments or doubts, leave them in the comment box and I will get back to you.